All right, so here's a few news articles. Let me try and get them down where I can control the tabs. Doesn't seem to be any way to move this thing. Nope. All right. There we go. All right. So there are only 4 forces of nature: the strong and weak nuclear force, gravitation, and electromagnetism. And that would fit with the string model, but there is a hint that there's a 5th force. Under certain conditions, you have an isotope, a beryllium, or another element that releases a particle which then emits 2 photons, and from the angles of the photons they can deduce that there's another particle emitted. This is how many particles were originally discovered. So this has only been reproduced a couple of times. It's still very new and not proven yet, but it suggests that there is a 5th force of nature. And if that is true, they're hoping it might lead to some of the unsolved mysteries. The biggest mystery in physics is the dark matter. 90% of the universe is some unseen, invisible stuff, because you can take the total amount of gravity, you can figure out how much mass there is in, say, a galaxy by watching the things orbit around it. But if you add up everything you can see, all the dust and stars and everything, it doesn't add up to enough at all. And they've even found cases where the dark matter is in a different physical location than the visible matter, and you can tell from the orbits of rotating things where it is. So there is some strange substance that makes up 90% of the universe, and we still have no real idea what it is. So anyway, there's a few mysteries yet to be solved there. This Muscles, a guy from the Wall of Sheep I know that gave talks here, he's a very good guy. He talked about how this will improve security. Amazon now supports maximum instant lifetime. You could make it so that each server is only used for 1 day and then discarded and replaced with a fresh image. And that would mean if anybody hacked into it, they'd only have it for a brief period of time. If it got malware on it or some kind of defect, it wouldn't last. So this is a good idea. This may help. There may be ways to make your server much safer this way. There's a similar procedure that I heard about on the Steve Gibson podcast, which you should all be listening to. GRC Security Now is a fantastic podcast, very informative. And he had one about short TLS lifetimes, which is a new technology from Cloudflare and other companies. There is a similar problem with certificates. When you connect to a secure website here, as I remember, it's hidden and I can't, the site is secure and there's a certificate. And notice they say the certificate is valid. Now that would be nice if that were true. But in fact, when they say it's valid, they don't really know that at all. Because what they do is they check that the issuer of the certificate is on the trusted list, and that the dates are within the approved dates, and that the domain name on the certificate matches the domain name up here, and that makes it valid. But the problem is it could have been stolen. And so there is supposed to be some certificate revocation process, but none of the certificate revocation processes have ever worked at all. The original one used certificate revocation lists that each ISP had to run, but they were too slow, so browsers would just give up and let you see the website whether it passed that test or not. There have been many, many attempts to secure this, and the latest attempt, which Cloudflare is pushing, is to use temporary certificates that are only good for a short period of time, like a day. And then you get a new certificate every day from an intermediate authority under your company's control. So you delegate the authority, and that way a certificate will not last very long. So if it gets compromised, it won't matter as much. That's the latest attempt to make this better. I know this is a big issue for Cloudflare. I've talked to the CEO about it a few years ago. One problem with Cloudflare is if you use Cloudflare and you're a bank, your HTTPS site, and you have the private key at the bank, but your customers are looking at an image of your bank on a local server, and that connection would have to have your private key, or it has to have a different certificate. And they have complicated systems where they set up sort of a VPN from one site to another. So the traffic is encrypted, but they do not have to hold your private key. And that's why they get to this sort of issue. They should somehow be able to delegate a key to a proxy server that lets it do HTTPS. This is another thing I got from the latest episode of Steve Gibson that helped me with today's lecture. This is a new GitHub project called CodeQL. This is something you use to do tests on the quality of your code as you're writing it. There are a few products like this now, cloud-based solutions that will automatically look for security vulnerabilities in your code on GitHub. And I wanted to write a project for this, but it looked pretty complicated to set up, and I'll show you. I used a much simpler free product to try it, and I was not impressed. But anyway, they claim this really works, and they've found 100 new CVEs in open source code. They were talking about the incredible amount of open source code that has never been audited, which is of course huge. And they had a fun statistic. They said right now there are 500 developers for every security professional. So they are writing junk far faster than we can secure it. And this is the beginning of attempts to try to make a really large scalable solution, some way to catch all the security flaws out there. Anyway, this was pretty funny. Nikki Haley forgot the password for her secure phone, so she just sent classified information through the insecure phone. And this is, of course, I'm sure this kind of thing happens all the time, but the point is, of course, the Republicans made a huge, huge big deal when Hillary did this. And of course, they're doing it too. It's, you know, as if, of course, only the Democrats seem to care that the Republicans are complete hypocrites and change their story every 5 minutes because they have Fox News. And they just don't know that anything bad ever happens on their side as long as they live in that bubble. Anyway, so City College is having huge budget cuts. People have told me that they're going to fire all the part-timers. That appears to be true. People are already having their classes canceled. Several teachers in our department had classes canceled today. So that means they have blocked all registration for next semester. The website is up, but you cannot register for classes because they know that many of the classes you see are not going to be offered. So on my website, I tell you what I'm going to teach next semester, and don't believe it. This is what I was going to teach next semester up to a week ago. But what I imagine is going to happen is they'll fire all the part-timers, and all the full-timers will have to go back and teach beginning courses to fill in. So anyway, I don't know what's going to happen. This is what I was planning to teach, but it's all up in the air. Now, there is a bond measure coming through in March. If they approve that, then we'll have money again. Other than that, we'll just shrink to a smaller college, but we're going to go through even more crazy turmoil here. Anyway.
I registered for classes today.
What's that?
I registered for classes today.
You registered for classes today?
Yeah.
Wow. You mean they let you register for individual classes?
Yeah, because if you're a disability student, you have the ability to apply early. So
well, they told us they blocked it, but maybe they didn't. That would be pretty normal around here, that they didn't actually block it. That's even more. The classes you signed up for may very well not happen. They're canceling them right now.
Well, the only thing is, I'm very unhappy because I don't like doing online classes. I need like 3 classes to get a degree, and 2 classes to get a degree. I couldn't get it on campus. I have to do it online. So I signed up for some classes, but I want to drop them, and hopefully you guys have it on campus.
Yeah, well, nobody knows what's happening, but I think there will be a lot of suffering trying to get good classes next semester. I think everyone's going to be very confused. Anyway, they're supposedly straightening it out this week, and we have a meeting next week, so maybe I'll know a little more. So this is pretty amazing. Docker, there have been warnings for a long time that Docker is not as safe as a virtual machine. And this is the worst vulnerability to date. I'd like to make a project out of this. What happens is, if you use Docker, Docker has a feature to copy. Docker is like a virtual machine. You're running an application inside a container, but it's not as separate from an operating system as a virtual machine. And there's a way to copy files from Docker onto the host. And it turns out that when it does that, it uses a library that loads from the container into the memory space of the host and then runs at root permissions on the host. So you can make a malicious Docker image with a malicious DIL inside it, and that will give you root of the host. And this is what people are most afraid of, is that your container will allow you to exploit and take over the host and then take over the other containers, because all the machines we're actually talking to are now containers. And if you could escape from the container and take over the host, then you could take over other servers and other customers of cloud services and stuff. So they patched this one, but there have been warnings right from the beginning that we shouldn't trust containers so much. They're intrinsically much more dangerous than virtual machines. But there's only a few exploits that come out. Yeah?
What is Docker?
Docker is a program that makes it possible to run very fast, isolated processes, which are sort of like cheroot jails. They are much simpler than virtual machines. They run on a thing called overlay FS, which is a layered file system. So the container sees a file system, and if a file that the container needs is equal to a file on the host, it doesn't make a second copy. It just uses the same file. But if it's different, it makes a second copy of only that file. So if you have a Linux host and a Linux container, it starts out at size 0. It's just a folder. And when you install software in the container, it gets a little bigger, but it's always much, much smaller than a virtual machine, which has a second whole copy of everything. That's what amazed me when virtual machines came out. They're incredibly inefficient. You have a whole nother copy of the whole operating system, which seems crazy, and that's what Docker avoids. That's why you can run like 30 containers on a computer that could only host maybe 3 virtual machines. They're much cheaper and much faster, and everybody's using them everywhere for that reason, but they're much less separated from the host, and therefore in principle more dangerous. Docker is the software, and the thing it runs are called containers instead of virtual machines. And they're everywhere. And I've got some projects where you play with them. They're very important these days, but they are notorious for being dangerous, and some of that is being realized. Anyway, so we're down to source code auditing, and this is an area that is important but frustrating. As far as I can tell, all the tools are terrible. And nothing much has changed. I had some really old tools I wrote in the lecture, so I went and found some new tools, and as far as I can tell, they don't work either. This would seem like the best way to get the security problems out of your stuff. You would look at the source code and scan for dangerous things like uncontrolled copies that can copy a command without checking the length, format prints of things without a format string, and so on. It would seem like you could just look for risky patterns of code, but and so there have been a bunch of tools. Cscope is one that was designed to do large products like the Linux kernel, so it's just huge. And there was something called ctags that would index your code and put tags all over it so you could easily find related pieces of code. You can just use a text editor and search through it for strings that appear to match unsafe practices. You can do that. What Microsoft actually did when they tried to get away from their world of buffer overflows is they changed C. They had a special custom library to remove the 10 most dangerous C functions and replace them with safer C functions, like you don't use string copy, you use string encopy, which only copies a certain number of characters, which is controlled, instead of copying a copy of uncontrolled length. And that they've open sourced that so everybody can use it. And that's what they use to cut the buffer overflows down in Windows. But all of these things are surprisingly ineffective. Anyway, so there's Splint is an old automated tool you'd run to detect vulnerabilities in your source code. And there's a whole series of other ones, typically specialized by one language to another. They don't seem to get updated very much. They don't seem to ever become too popular. There was one called CPP check, and in earlier versions of this course, I had students play with it, but I was very disappointed at the results. I tried running it on the code we've used for the early exploits, like a buffer overflow, a format string vulnerability, a heap overflow, and it didn't find most of the vulnerabilities. So here's a simple case of a heap overflow you did in the projects. You allocate some stuff here, and you allocate some more stuff here, and then you use string copy to copy an argument into one of those heap chunks without controlling the length. So this creates a heap overflow. And when you run CPP check, it tells you about the memory leak, but not the overflow. And I think, I don't really understand why these tools are so terrible, but I have a hypothesis. And my hypothesis is that they are written by coders. And as I was just telling you, there are 500 coders for every security professional. And it is absolutely true, and has been for decades, that almost all of the coders know nothing at all about security. Something Dan Kaminsky said at a conference about 5 years ago. He said, we should start giving talks at coding conferences. So I went to coding conferences, and I started giving talks, and I was horrified. They're very, very unaware of security problems. So what happened here is there's 2 problems in this code. The one that catches me as a security professional is this string copy at the bottom means you can do an overflow and take over the machine. But what a coder notices is that you allocated something and you never freed it. So that's a memory leak that will gradually use up the memory in the machine and cause it to crash. And that's a performance problem. And coders care about performance, but they're typically unaware of security. So this tool finds the memory leaks and does not find the overflow, because I think they're thinking like a coder. They're thinking of how to make it faster and smaller, but they're unaware of even the top 10 OWASP risks they should be looking for. And I think that's the problem with all these tools. The people that write them, of course, are experts in that language, so they're coders, and that typically means they're not experts about security, because people typically learn only one or the other and not both. Anyway, so I ran it on this format string code here that just prints something without a format string. This should be the easiest thing in the world to catch, and it doesn't complain. It says buffer overrun possible because it has a string copy, which is true, by the way. So I give it credit for that, but it didn't find the format string, which is kind of amazingly bad. And so there's another thing called Flaw Finder in Kali, which is an old tool, and I thought it was better when I tried it. And I thought of giving you a homework project this, but I decided to try some cloud-based tools, hoping they would be better, and they weren't. Anyway, so there's two methodologies of doing source code reviews. One is the kind we've been talking about so far, where you would have a list of known patterns of code, and you'd look for those patterns, like a print statement without a format, or a copy that copies an unlimited amount of length into something. Then you just look for specific errors in just a few lines of code. Now, the good thing about this is it's very easy to find. The bad thing about it is you're going to have false positives. In all security tools, false positives are terrible. By the way, I wonder if I ever started recording. I have a feeling I forgot. Nope, good. I did apparently remember to start recording. Good. Anyway, so the problem is false positives really waste your time, and everybody gets really angry about them because, and this is going to have false positives because, for example, if you have a print with no format statement, it isn't a vulnerability unless the contents is under control of the attacker. And frequently will just be for an error message or something going into a log that doesn't have any user-controlled data. So it'll tell you have 100 problems and none of them are exploitable. So you're wasting your time patching those problems. So that's not so good. Then there's a bottom-up approach. Let me see if I can get this Zoom thing out of the way. This is where you read large portions of code and try to understand what's really happening in the code. This is, of course, very time-consuming, but it might be a better way to find bugs, but I don't know how many people are willing to invest this time. Really, you're having to have someone review it who goes through a large portion of the work of the designer that designed the code. So what most auditors use is a mixture of the two. They try to find where user input comes in, and they try to track what code handles the user input, and then see if it has obvious errors there. That is a way to get to the part that matters. This is what most people do to try to avoid auditing the whole code base, which is too time-consuming. So there's general vulnerability classes. Logic errors are real important, and these are very hard to catch. Like the one I've mentioned before, Microsoft and Apple made a thumbprint reader for you to log in, and the way it worked was you put your thumbprint on it, it would identify your thumb, then it would type in your password for you. So the thumbprint reader had to have a database in plain text of all the passwords, and that's a huge flaw, which neither Microsoft nor Apple detected, and they manufactured this thing and sold it for a long time. And that is an error, which is not as simple as one bad line of code. It's a logical mistake that harms security, which is not fixable by fixing one line of code. It's the kind of thing that requires human understanding, and that's called a logic error. Another one was wildcard certificates. This was, in I think 2008 or 2010, this was the toast of DEF CON. Marlon Spike and Dan Kaminsky separately discovered this. It was bloody awesome. And it came about because the certificate authority code is very, very old. HTTPS certificates came around a long time ago, and they wrote the server code in Pascal. Pascal is almost a dead language. But one thing about Pascal is Pascal does not use null terminators to end strings. Pascal uses the first byte to specify the length of a string, so it might say 10, and then the next 10 bytes of the string. So in Pascal, you can put null bytes in a string, and they are considered just valid characters like any other characters. But in C, null bytes terminate the string, as you've seen in a lot of the attacks here. So you could buy a certificate for star nullbyte.evil.com. And Pascal would just see that as a valid subdomain of evil.com, like www.evil.com or games.evil.com. So if you own a domain, you could totally buy a certificate like this. So you could own it, and it would be valid, purchased from a valid trusted certificate authority. And then if you opened bankofamerica.com with this certificate, the C-based browser would compare bankofamerica.com to star, which is the wildcard. So this certificate will sign every domain, and it will pass the test until your browser will accept it as a valid certificate. And this was true of certificates sold at that time. And they bought, various researchers bought about a dozen or 2 dozen of them, and they're floating around for a while. This was another very subtle logic flaw. It came from the Pascal code running as intended and the C code running as intended, but the misunderstanding here meant that you could do something very wrong, and yet there's no single line of code or single bug causing this. It's a logic error. All right, so this kind of stuff, of course, persists to this day. There's no scanner that can find this stuff. Really, only an intelligent human can find this, and that's why you need a human judgment. I just had a meeting with a pen tester. We're looking at hiring this pen tester to help us in our engagements because of this reason. I don't feel good about leading a application pen test in a real engagement with a high-value customer because I haven't done it. And it turns out that I know the theory, but you have to have real experience to know what matters and what doesn't in real business. And it's the same kind of thing here. You'd have to have experience to catch this kind of bug. That's why they pay you money. There are pen testers that just run automated scanners and hand it to the client, and that is of no value because you have to look at the results and figure out what it means to that customer, what matters and what doesn't. That's what they're paying you for, not the tool, but the human judgment on the tool. It's like you go to your doctor and you probably have many problems, but you need guidance. What can I do to make me better? Which one of these problems really matter? Anyway, so here's the original kind of bugs that caught everyone's attention because of the aleph null buffer overflow. They say you get string copy, string print, string cat gets. These are what we've been doing in this class, the first stuff, classic buffer overflows. And those have declined because some people say they're catching it with code reviews, but I think they're mostly catching it with things like data execution prevention and address space layout randomization. So the operating system has been hardened so that even if the developer makes this mistake, it is less likely that you can actually exploit it on a modern system. But anyway, these are no longer that common anymore. This is a very interesting chart. I wish there was a more updated one. This one's from 2013, but it goes back to 2006. And the blue bar at the bottom is the Stack Overflows. They were really big in like 2007. They were more than half of all the vulnerabilities in Microsoft. And that's when, in 2008, is when Vista came out, and Microsoft vigorously started trying to fix this. And as you can see, they had a lot of success. And by 2012 or 2013, this was down to less than 10% of the vulns. That's Microsoft's defenses removing the effect of simple buffer overflows. That's stack corruption. Now you got heap corruption as the yellow bar, and it pretty much kept constant. And then use after free became really big. That turned out to be the modern one. And there are others out here, but it's a very interesting chart to see how these various bug classes come in and out of prevalence. And that's because there's a time when nobody knows about it and it's all over the place. Then they discover it and it's exploited. Then they discover a defense and they wipe it out. And then something else becomes the new hotness. But anyway, it's interesting to watch them come through. I know every version of Windows is much more secure, and they've been putting a lot of attention on heap attacks, and you can see why. The heap corruption is what, 20 or 30% all the time here. In Windows 8 and Windows 10 and the corresponding server products, they put in a lot more defenses on the heap. So if we had more modern versions of this, I suspect that yellow bar would be going down by quite a lot. Anyway, here's how people were bypassing address space layout randomization and data execution prevention. Finding a DIL that doesn't have address space layout randomization turned on is the most popular thing here. The only other way to do it is to find some information disclosure that tells you where you are. To bypass data execution prevention, it's return-oriented programming like we've used in this class. That's the main way. The other technique, of course, is heap spraying. Heap spraying is where you fill all available memory with copies of your exploit so you don't have to know where anything is. This became largely patched, I think, by Edge. This was an Internet Explorer property that would store strings in the browser from JavaScript directly in memory, and they no longer do it that way. They encode strings differently in Edge, so this is more difficult to do. And I don't think heap sprays are that common anymore. As I mentioned before, I had an old heap spray project from Windows 2008, and I tried to update it and add it to this class, and I was unable to make it work on modern browsers. Even the version of Internet Explorer, Windows 2016, would not fall for it. So heap sprays seem to me to be kind of out of date, at least the old kind. There may be some new way to do it, but I couldn't find an easy way to do it anymore. Anyway, so format strings are just ridiculous. Here's vulnerable. You just print something out. You should have a format string like %s, but if you don't, then if I can control that string, I can put the format string in and then use it, as we've done, to write to memory and take it over. So that would be there. Another thing that happens quite a lot is that the coder tries to put a bounds check, like they're copying a string and they try to make sure it's not too long, but they make some kind of mistake, so it's still possible to put in something too long. Here's one, Snort, for example, the security product. filtering your network, filtering your text. It did a bunch of fragments, and it checked each fragment to make sure it wasn't too big, but it was all the fragments added together that had to fit in the buffer, and it didn't check that. So you could feed it small fragments, each of which was below the limit, and they would add up to something above the limit. The same thing happened in the famous ping of death attack from the 90s. You would send a ping, which would come in as a bunch of small packets, and when they added them up on the server, it would overrun the buffer and cause the server to crash. Even though each individual packet, of course, had only an acceptable amount of contents. So here's the processor, and here's total length, and it uses the total length down here, but up here it just checks the length of one against the size, not the total length. And that's the kind of logic error. And you won't find any one line here with a mistake in it. That's the same thing's true of the flaw in Vista that caused blue screens of death. They had a variable compared to something, and it turned out it was the wrong variable. It should have been J, but it was really I. And again, no code scanner can find that, but it can lead to a vulnerability. Then there's loops. You have while loops and for loops and do loops, and you often have loops within loops and ifs within ifs, and it's very easy to get confused and have unexpected combination of conditions. So there's one here where this would, certain conversions from character and integer types would cause a length check to be disabled. See, when you change a variable from one format to another, it often gets longer. And if you check the length and then there's a conversion after that, it can then go too far. So this caused people to have a buffer overrun. And so here's a send mail exploit would look something like this. You'd have all these special characters in order to do it, because they would then have to be interpreted and changed, and that's what would cause the overflow. Then there's very common off by one vulnerabilities. For some reason in C, loops traditionally start at 0 and go up to n-1 for n reps, and people just constantly get confused. Have one extra rep, one less rep, so when they try to limit something or check something or do something a certain number of times, they do it too many times or not enough, and many times this leads to code execution. Here's an example from Apache. So if something here about the length is true, and if something about this length is true, then I go here and assign allocation to this, otherwise I do something else, and it turns out under certain conditions, the allocation length is off by 1. So the allocated space is 1 too short, and you're able to override by 1 byte, and that could be enough to cause you to go out of bounds, especially in C, where even going 1 byte too far might mean you can avoid the null terminator, and now it gets much longer as it blends into the next variable. So here again is another one of these where they check for some length, but if they're going to have a quote, then if they found a quote in there and it wasn't matched, it would add another quote to match the missing quote, and that extra character happens after the length check. So again, you can end up with something longer than it should be. String ncat null terminates its output string, but the problem is, since you have to add an extra byte to a C string to put a terminator on there, it adds an extra byte. And if you look at the string n copy and all the other C functions that try to copy things, they all have huge defects about the null terminator. It's just pretty awful. If you have a language like Python or Visual Basic, it will just automatically resize variables as needed. But C, it is just very, very easy to get confused and lose the null terminator or have the null terminator go too far. It's easy to lose control. Even these attempts to clean up C, it still remains very easy to accidentally copy a string in a way that causes overrun. All right, I mentioned this before. If your string does not get the null terminator because you copied it in some way that lost it, which is very easy to do, then of course it'll just interpret the next string as part of this string, and the string will suddenly get much longer. And you may be able to write to a variable that you weren't supposed to write to. And we've had exploits like that. The earliest overflow, where we had data overflowing from one string to the next string, worked this way. All right, so here's string n copy. If you try to do a string n copy from a string that's 11 long to a string that's 10 long, it will just copy the first 10 bytes and then quit, and it won't write the null terminator. So you'll end up with an unterminated 10-byte string, which will leak into the next variable. This kind of thing happens over and over and over again in C. So the first string copy here will not null terminate the buffer, so the second string copy is now unsafe, even though both buffers are the same size because it's fouled it up. You'd have to add something here that automatically puts the null terminator in there every time so that there's a separation between one variable and the next, or you're referring to something longer than a variable without knowing it. That idea of the null terminator is probably not that brilliant an idea. I think this would be a lot safer if we just had Pascal type strings, but you know, C is what it is. We're stuck with it. That's why various people have talked about getting rid of C. Microsoft has even investigated switching to Rust. Apparently, if you code in Rust, none of this will happen. But Microsoft has an enormous legacy code base now written in C. So even if they decided to change to Rust today, it would probably be 10 years before they got there. And third-party developers, of course, will continue to write in C for a long time. The point of C, there are two huge advantages. The first thing is the code runs really fast because C is very close to assembly language. It's almost raw assembler. And the second thing is the code is hard to steal because compiled C, as you have seen in this class, is really hard to understand. And even if you disassemble it to assembly code, it's hard to read. So you can distribute something like Microsoft Office, which a lot of people would like to steal, and giving them a compiled version, they really can't get back to the source code in any usable way. So these are selling points that keep C popular, even though it leads to all these security problems. All right, and so like I say, there's ways to skip past null termination. If you process more than one character at a time in your string, then you might skip past it. There's a few of these where this happened. Yeah, here's one. In Apache, is trying to read a URI. And it might have HTTP : / / So if it finds certain characters, it will say, oh, jump ahead by 3 because this is the : //. So that means if you put the colon someplace else, it will skip over the next 2 characters so you can jump past the null terminator and read the next variable. So, you know, there's, again, a logic flaw. You're looking for the null terminator, and yet under certain conditions, you jump ahead by 3. There's no one line that's broken here, but the end result is you have a hole. All right, that's the game here. All right. And then, of course, there's integer vulnerabilities. The king of this is the, there's a fun one, which I've got in one of my classes, I think 123, where you steal money. This really happened to POWH coin. There was a real cryptocurrency designed by this, and they forgot about integer overflows. There was a way to take money from an empty account, so it would underflow and turn into a huge number so you could steal all the money. And that's what happened. They put $1 million in it and somebody stole all the money by just draining money from it and putting your account empty and then spending $1 from the empty account. And now they had an infinite balance, so they could just take all the money. This kind of thing happens over and over again. And this happens to Python and JavaScript too, where you have one type of data compared to another type of data. Many, many flaws can happen here, where something that is an integer is interpreted as a string or as a floating point. So when you do a comparison, it has unexpected consequences. So buff size is a signed integer, but R remaining is signed. That means you can make the buffer extremely big and it will be interpreted as a negative number and therefore not big, because you check to see if the remaining space is greater than buff size. And if it's, for example, a 16-bit integer, an unsigned number would go from 0 to 65,000, but a signed integer would go from minus 32,000 to plus 32,000. So if I'm able to put 40,000 characters in this R remaining, that will be interpreted as minus 8,000 and not bigger than the size. So this is one of the many overflow and underflow errors of numbers. Because the numbers in the computer are all binary, it is easy for the coder to get confused, for the program to get confused. So here's typical conversions showing you this. The unsigned number goes from 0 to 65,000, but the signed number goes from minus 32,000 to plus 32,000. So anyway, so here's another one that got a lot of attention. Here, if someone logs in with a password, and then you hash the password with 512, and then you compare it to the password in the database. This is what was used in, say, I think this is PHP. If the password in the database equals the hash password from the user, then you let them in. The problem here is 2 equals compares one value to another. And if the hashed password starts with 0E, and the rest of it is numbers, then this will be interpreted as a number, not a string, because 0e means 0 times 10 to the something. So it's equal to 0. So under certain conditions, this will be interpreted as a number instead of a string. And if you use 2 equals, it will do a type conversion. So it will turn this into a number, then it will compare it to this, which is a string, and it will never be equal. Or if that's the point, you get confused. What you really have to do is have 3 equal signs in this language, which means the 2 things must agree both in value and in type. And many developers don't know that. And so they have unexpected flaws. I made a mistake like this in some of my projects. Last semester and the semester before, I used to have a form at the end of every project that would put your score right in Canvas. And some of them, I made a mistake like this, and you could just leave the answer blank and you'd get credit. Some students found that. It's far easier to make that kind of mistake than you might think.
Isn't this, because 2 equals is equal.
Yeah,
so
1 equals assign. If you have 1 equals, it would assign this value to that variable.
Yeah,
2 equals means it tries to make sure that this, when evaluated, is equal to that when evaluated. But 3 equals means this must be exactly equal to that, even in both data type and value.
Okay, that's the operator.
Yeah, there's 3 operators: equals, double equals, and triple equals in PHP. But many people don't know that. They just use double equals because that's all it is in C. And that's why you could argue that all this comes from people not carefully reading the manual and understanding all the details of every function they use. But I've done enough development to know how ridiculous that is. I mean, nobody does that. A 2 equals means it will evaluate the expression on the right and evaluate the expression on the left and decide if they're equal. And it will guess to determine what data type it is. So if it's not clear whether it's a string or a number, it will guess, and it might guess wrong. So I think, yeah, so here's the point. If you hash it and get a number like this, that is 0. That's always 0. And what that means is this will match any hash that's also 0. So there's a whole bunch of possible passwords that are all considered equal. They're all considered equal to 0. So if I can log in with the wrong password, I can just use any of the passwords that evaluate to this kind of string. At first, I thought this was a big deal, and then I realized this is actually very rare because you have to have this whole thing without any letters in it, which means you have like 10 out of 16 chances of each one of these, and there's a lot of them. So in fact, only like 1 in a million passwords have this property. But in principle, it does mean that if you have a large database, there are some passwords that can be spoofed with other passwords. Anyway, then there's double free. This is one that's pretty common. If you have a heap, you allocate space on the heap and you point to it with a handle. Under some conditions, you'll have another function that creates a second handle pointing to the same object. And now, if the first routine frees it, the second routine might try to free the same thing that has already been freed. And what that does is it tries to delete an item from the heap and fix the pointers around it, and that item is no longer in use. So what it essentially means is, like the heap exploits we did here, there is some data there that is used to do write operations, where the data being written is no longer under control of the programmer, and it's possible that you will be able to change it some other way, and then I can control the write and take over the machine. So that's a double free vulnerability. And it's like dangling pointers. So here's a good practice to prevent this. Whenever you free something, immediately set that pointer to null, so that even if you try to reuse it somewhere, it will have no effect. This is the correct good practice. Otherwise, this is an example of the many dangling pointer vulnerabilities where you have 2 pointers to something and you deallocate one and you still have a pointer pointing to an area of memory that is no longer reserved for that use. So when you read or write to that memory later, you're referring to something that you shouldn't be able to get to. And so here's another picture of the dangling pointer. So I have a dangling pointer here pointing to this memory location, and then other pointers. And the dangling pointer points to a deleted object. So it's pointing to an area of memory that is no longer allocated for this use. And when that memory is reused later in the program, because the whole point of the heap is you keep reallocating the same memory over and over, then I will have another way to read or write to that, which now has a different meaning. So it gives you a memory corruption vulnerability, which may be exploitable. All right. And let me find the way to mute people, because the mute all feature does not work correctly in Zoom. Zoom is free, but it's got its bugs. Anyway, all right. And Then you've got uninitialized variable usage. This is a really common one. I remember when I started coding back in the old days with BASIC, you could just use a variable and every variable was always 0 until you defined it. And the same thing was true of Fortran. And a lot of people do this in other languages like C, but it's manifestly not true in C. If you use a variable, you declare like integer I, and then you use I without ever assigning it to anything, it will just contain random data, just like some from the stack or something. So it's often the case that you forget to initialize something and you're referring to something that has data left over, and that'll just be data left over from an earlier process. So it's kind of like what you get from a format string vulnerability. You get the ability to read or write to memory that contains leftover data from some other process or from some earlier part of this process. So anyway, these things tend to lead to crashes, but there might be ones in code. And in general, by the way, the best place to look for vulnerabilities like this is in the code that's not used much, because of course the developer will test the code, and if it crashes, they'll fix it. So the part that's likely to have a huge error is the part that's never used, like the password reset function. There was one about 5 years ago where all the cloud machines that people use for everything on all the cloud providers turned out to be vulnerable because they all had virtual floppy drives that had a buffer overflow, and nobody even knew they had virtual floppy drives. It was just the default setting of the cloud hosting service, QEMU, QEMU, which is what they almost all use. The machines it created had a virtual floppy drive, which nobody noticed or cared about, and it had been sitting there for years, and it had a flaw. So that's where you'll usually find this nasty stuff, is in code that isn't used much, so nobody notices it has a flaw. So if data, so here's some function that takes data and then some integer, and if data is like greater than 1 or something, then it goes here. Otherwise, it goes down here. And here it always frees test, but notice only if data passed this test did it allocate test. Otherwise, it tries to free something here which was never defined. So now you have like a double free. You're freeing something which was not in fact allocated, and therefore you engage in some write operations using data that was not properly controlled. And if you find a way to write to those areas, then you'll be able to get a user attacker-controlled write operation, which can give you control of the machine. So to exploit this, you'd have to find out what controls that data and see if you can get it under control of the attacker. You'll use after free vulnerabilities. Heap buffers are temporary, but a program might use a pointer after free, and then it's going to be pointing to RAM that is now being used by something else. And of course, we talked about that. All right, then there's multi-threaded issues. This is something I've seen before. It's pretty amazing. You write a program, it's fine. When you actually deploy it and use it in production, it's not fine because it can handle a small load. This, for example, one practice a lot of sloppy coders do is they store things in the temp folder on Linux machines. They will have some information coming from the user, they'll stick it in a temp folder, and then they'll read it later. The problem is the temp folder is shared by all the processes, and if you have a multi-threaded code where it handles many users at the same time by making multiple copies of it, they will all keep writing to the same file, overwriting each other. And so this leads to errors, which I've heard students report this, and I've seen news articles about this, how people open up their phone and look at their Gmail, and it's somebody else's mail. And then they try tomorrow and it's okay again, or Yahoo. This happens a lot with cloud services from this kind of error. They made some assumption that something could be stored and then read later, and they didn't think about what would happen when many users are using it at once, where it actually gets mixed up and you see somebody else's stuff. This kind of thing tends to happen, and it's very hard to detect because testing it in like test conditions usually don't have enough load to trigger it. All right, anyway, so I got some cahoots about that stuff. And then I'll show you the latest project, which is a lot less exciting than I had hoped it would be, but you do have a project if you want to do it. So this is 127 source code auditing. All right. All right. I feel like there's some meaning to some of these names that I don't understand, but anyway. I'll give it a few more seconds. Okay, I guess this is it. All right. So what does string copy cause? Simple stack buffer overflow in most cases. That's the old-fashioned vulnerability. All right. What happens from comparing one data type to another? That's commonly the problem with integers. And the example we saw was you compared an unsigned integer to a signed integer, leading to unexpected results. All right, which vulnerability comes from one part of the program corrupting another part's data? Okay, that's multi-threading. One instance, the program will write on some data shared by another. All right. Which vulnerability is likely if there are multiple pointers to an object? That's double free, of course. You might free it twice. All right, which one exposes data from the stack? Okay, the format strings, you remember this one? That's the most obvious thing it does. You can just print data and it shows you random data from the stack. All right. And which one is likely when a loop processes several bytes at a time? Okay, that you might skip past the null. All right, good. So you'll see the winners, M dots and Ken and Vin. Is Vin a real name? I think it might be. All right, good. All right, so the only remaining thing is to show you the latest project, which is, like I say, kind of underwhelming. But I wanted to do a source code auditing project, and those old ones were pretty lame, so I thought things might have improved. And from what I can tell, they haven't. Yeah. What's that? I am really now what?
You are running out of battery.
Running out of battery. Yeah, I know. It'll be all right. Yeah. Anyway, the so here's the latest one. I found this thing called Codacy, which is free, and it turns out to be pretty easy to use, but amazingly ineffective. So you have to make a GitHub account, and you have to have some code. And so I thought we'd use Bowne server. Bowne server is that Windows-based server that we used for a whole bunch of Windows attacks. So it's all full of vulnerabilities. So I figured, well, let's see what it does with that. And if you have a GitHub thing, see, here's the original code for Bowne server. And if you make a GitHub account, you can just fork anything. And then you get your own copy in your account of the entire source code. Now you can modify. That's the whole point of open source code. So you make your own GitHub account, you make a fork of this, and now you have a copy of it. And now you can send it to your Codacy account. Add your Bowne server repository to it, and now it will scan that code. It takes about 5 minutes to scan it, although I think when you people do it, it won't take that long, because I think it'll just find my analysis and run it again. And when you look through it, you will find it finds very little. It did find some of these string n copies and said, maybe that's not safe. This thing has a bunch of buffer overflows, and it found a memory leak, which you can see, but it really didn't find much. And the thing that really surprised me is then I fed in another example from your classes. Here's the same old thing. This is a format string vulnerability. It prints something that came from the user without a format string. That's a pretty bad error, and it doesn't find it, just like the other ones. You can put this stuff in, you can scan it, and it's not going to find it. So that's pretty rude. Anyway, thought I might have to change that image. Yeah, we are. It's supposed to, anyway, but it's not going to find it. And so that's the, anyway, like all the other code review projects I had, there were several others I had in previous versions, which I took out because they're all pretty disappointing. These things are amazingly bad. The new one that just came out from GitHub might be better, but it's very complicated to set up and use. It's not very automatic at all. It's actually kind of like Splunk. You spend a lot of time setting it up, and then you run these queries against your code. And they give you a library of queries, and they encourage you to write your own queries. So it's not automatic at all. You have to know, you have to write like a regular expression to look for things in the code, which, you know, that's going to be up to your skill running it. I mean, you could do that without any tool at all. You could just be running complicated regular expressions to find patterns in code. But hopefully, eventually, they'll have a good enough library of expressions it can be a little more automatic. Anyway, so for what it's worth, you can try code review. I don't know, man. I'm not feeling very good about code review. There are other tools that automatically build right into Visual Studio. So it will automatically do this review. And this tool and other tools will automatically scan your GitHub repository for every commit or every day or something so they can keep you up to compliance. But since the scanners don't seem to detect vulnerabilities very well, it's of questionable value. Anyway, that's what I wanted to show you. And I'll stick around for a while if anybody wants help on projects. I see a chat message. Yes, I'm Vin. Good, good. Vin is Vin. Good. All right. So anyway, that's enough for tonight. Next week, I will have, there's not a guest speaker. I think there's a guest speaker on the schedule, but there isn't one. So I will just move a chapter around or something. So I'll change this. Yeah, we'll probably just go on to some other topic here, like the Hopper debugger next time. Anyway, I'll also put up in Canvas this week, I'll put up the point totals required to get certain grades because everybody's getting concerned about their grade, which is understandable. There'll be a announcement at the top that just has the totals. Don't pay attention to percentages you see in Canvas. All that matters is the total points. And I'll have the chart up there later this week. Any questions about anything? Well, I'm going to stop the share and I'll see you folks next week. And I'll stick around here.